Everyone. So today we're going to be talking about the properties of parallel lines. Last night I asked you to do the warm up. So let's just check that you got your answers right based on what we were learning in class yesterday. So first of all, 5 and 3 are same side interior angles because they are on the inside of M and L, the two lines, and they're on the same side of the transversal, which is S. Angle 4 and angle 5 are alternate interior angles on the alternate sides of the transversal. Angle 7 and angle 6 are corresponding angles. Angle 8 and angle 5 are corresponding angles because they are in the corresponding same location relative to the transversal. Angle 4 is alternate interior to angle 5. I think that's a repeat. It asks you to name what types of angles 3 and 7 were. Those, again, were alternate interior angles because they were on alternate sides of the transversal on the interior of the two lines being cut. 6 and 1 are, we actually did not review these that much, but these are called alternate exterior angles. And 7 and 1, we still know those are vertical angles. And we know that vertical angles are congruent by the vertical angle theorem. Okay, but today what we're going to talk about is special things that happen to these angles if the two lines are parallel. Okay, so first we're going to look at something called the corresponding angle postulate. Now in class tomorrow we're going to prove these, but today we're going to actually talk about them. If it's a postulate, then you have to accept it without proof. So I'm not going to prove the corresponding angle postulate. I'm going to tell you it's true, and you're going to believe me. But we're going to discuss that a little bit more tomorrow. But the corresponding angle postulate says that if two parallel lines, so the corresponding angle postulate only works with parallel lines. If two parallel lines are cut by a transversal, then. Okay, so let's just actually start that part. Let's draw two parallel lines. Now, when I draw two lines and I want them to be parallel, we talked about the fact that you have to put something called an arrowhead on them. That indicates, that's like those hash marks that means congruent. This means they're parallel. When we draw parallel lines and we're going to put the hash mark, we actually do not have to put arrows at the end. So you can leave lines like that. As long as the arrowheads are there, we know that they're parallel lines. So if two parallel lines are cut by a transversal, so I'm going to actually draw in a red transversal, then corresponding angles so here's the corresponding angle, so 1 and 2 or 3 and 4. Corresponding angles are congruent. Okay, so that means that 1 would be equal to 2 and 3 would be equal to 4. Now, you might also say that all 3 of those are equal, or all 4 of those are equal, and that is true, but we want to make sure that we understand that corresponding angles are congruent. 1 and 2 are corresponding, 3 and 4 are corresponding. There's other corresponding angles there as well. This and this are corresponding, this and this are corresponding. So that's the corresponding angle postulate, and we're going to have to put that to use today. All right, now, based on the corresponding angle postulate, tomorrow in class, we're going to prove two new theorems. The first one is called the alternate interior angle theorem. Again, these theorems relate to parallel lines, so that's important. The alternate interior angle theorem says that if two parallel lines, again, these only relate to parallel lines, are cut by a transversal, then alternate interior angles are congruent. Okay, so let's draw it. We are going to draw just two parallel lines cut by a transversal. Alternate interior angles would be something like this, A and B. Well, those are alternate interior angles and they would be congruent as long as the lines are parallel. So A and B. And we also should know that these angles here and here are also alternate interior angles. They would be congruent to each other. The blue ones would be congruent and the red ones would be congruent. Alternate interior angle theorem. Again, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. All right, the last one we're going to talk about today is the same side interior angle theorem. Remember, same side interior angles are angles that are on the same side of the transversal in between on the interior of the lines. Well, now again, we're talking about parallel lines. So if two parallel lines are cut by a transversal, then, and we got to put our parallel in, then all same side interior angles are supplementary. One of the ways I remember that is I write same side sup, same side sup, same side sup, SSS, same side sup. Supplementary means that they add to, I can hear you say it, 180 degrees. All right, so let's put this to use. Let's fill in the blanks first and then in review, and then we're going to put it to use in problems. If two parallel lines are cut by transversal, then corresponding angles are congruent, which means equals. Alternate interior angles are congruent, which means equals. And same side interiors angles are supplementary, which means they add to 180 degrees. All right, so let's look at some examples of this. All right, here we have two parallel lines cut by a transversal. Now, you may notice we have two transversals, so we actually have to be very careful. All right, so this is right here, 130 degrees. So the first thing that I want to do is I tend to look for corresponding angles first. I just always do that. So I see that 130 and angle 2 are congruent to each other because they're corresponding angles, and I can use the corresponding angle postulate. That tells me that angle 2 is 130 degrees. After I go through the corresponding angles, I tend to go to the vertical angles if there are any. So I see that 3 and 6 are vertical. So 3 is congruent to 2, and 6 is congruent to 3. So then this is 130, and this is 130. All right, so angle 3 is 130, angle 6 is 130. All right, angle 1. Now, look, you might see that they are a linear pair. So if this is 130, then angle 1 has to be 50 because 1 and 2 form a linear pair. By the linear pair postulate, it tells me they equal 180. So angle 1 is 50 degrees. All right, angle 1 is vertical to angle 4. So angle 4 then is 50 degrees. Now, I'm kind of stuck here because I want you to notice that angle 4 and angle 5 are alternate interior angles. Now, you may see this another way, but I want you to notice that alternate interior angles, let me actually make this a little thinner. Alternate interior angles form a Z. I'm highlighting it. They always form a Z. The top and the bottom of the Z are the parallel lines, and the connector of the Z is the transversal. So I can always look for those if I look for, and sometimes the Z's are funny shaped, but I wanted you to be able to see that. So that makes angle 5 50, and angle 7 is congruent to 50 because they're vertical angles, so that's 50. All right, now I got to go over to angle 8. Now, this is a new transversal. This is, say, transversal M. It is being, these are two parallel lines cut by a transversal, and you may notice these are corresponding angles. And corresponding angles are congruent, so then angle 8 would be 90 degrees, because what does that box mean? It means that the angles are 90 degrees. So that's how we use all these properties. Now, you may notice that it wasn't just the alternate interior and the corresponding angles that we used. We used vertical angles. We used linear pairs. So there's a lot of things for us to consider. All right, let's look at something different. This picture, I want you to go ahead and mark these lines parallel and these lines parallel. Now, you may notice that on these two lines, I used 2 of the arrowheads. That's because those are the ones that are parallel to each other. So there has to be some distinction between the two. All right, so always want to find, go in alphabetical order. Usually it's easier that way. And I look at X and 110. For me, what I do is I highlight the sides of the angles and I connect them. That tells me that these are the two parallel lines And this is the common line, which is the transversal. If that is the transversal, then these are on the inside of the lines. So they are same side interior angles, and same side interior angles are supplementary. So they equal 180 degrees. So x plus 110 equals 180, so then x has to be 70 degrees. Okay, I'm going to erase that part so that it's not in my way anymore. Now I'm going to move on to y. Okay, so because there's two sets of parallel lines, I have to be very careful. Now I know that this is 70 degrees. I'm going to write it in for myself. And now I'm looking at y. So I highlight the sides of y, and I see that if I extend it, then these are the parallel lines. And this is the transversal. And you may notice that 2y and 70 are corresponding angles, which are congruent. So I can say that 2y equals 70, so y equals 35 by division. So y is 35 degrees. I'm sorry, y is 35. And so then this angle is 70 degrees. We know that because they're congruent. All right, now we move on to z. I'm going to highlight the sides of z, and I see that there's two options. I can see that z and 70 are supplementary, or I can see that z and 110 are corresponding. I'm going to go with the corresponding. So I'm going to make these congruent to each other. And so I can see that 110 equals 2z. I'm going to divide by 2, and I get that z equals 55 degrees. I'm sorry, z equals 55. I keep saying degrees. So z equals 55. The angle itself is 110 degrees. All right, now they get messy, so you got to be really, really careful, but the colors will definitely help as these progressively get harder. Let's try another one. Here we have two sets of parallel lines. So I'm going to start with the angle I have. I see angle 40, and I want to see if I can find anything that relates to it. So I look at its sides, and I see that y, if I extend one of its sides, has a relationship with it. So y is corresponding to it, which would make it 40 degrees. Okay. I see x over here, and I'm going to use a different color. I see 2x, and if I extend one of the sides to 2x, I can actually find my way to the 40. And if you look, there's that beautiful z. So these are alternate interior angles, and they are congruent. So 2x equals 40, and x equals 20. Okay? All right, and then z. All right, so I know that this whole angle right here is 40. Couple ways I can do this. I can say that y and z are supplementary, or I can say 40 degrees and z are supplementary because they are same side interior angles. So I would say that z has to be 140 because 140 and 40 have to add to 180. All right, so hopefully this is coming together for you. What I'd like you to do is I'd like you to try the next example and press pause, try it, and come back. Okay, so you're back. Hopefully what you saw is that 16x and 3x are same side interior angles. So you wrote an equation, 16x plus 3x equals 180 degrees. 16 and 13 is 19x equals 180. And then you divide by 19. So 19 goes into 180. How many times? Let's see. 9 times 5, 20, 40, 60, maybe 8 times. 8 times 9 is 72. That's going to be too small, so I'm going to try 9. 9 times 9 is 81. 9 times 1 plus 8 is 17. And I get 9 over 19. So x is equal to 9 over 19. 9 and 9 over 19. Okay, so not a pretty number, and that can be true. All right, so 9 and 9 over 19. 5y and 90 are same side interior angles as well, so then 5y plus 90 equals 180. 5y equals 90, and y equals, let's see, 5 goes into 9 one time, and so 18. So y is equal to 18. Awesome. All right, last thing we're going to do, we're going to look at how we can name theorems and postulates based on given information. So first, what I'd like you to do is I'd like you to mark those parallel, and we look at it. If 1 and 5 are congruent, those are corresponding angles. If the lines are parallel, they would be, the theorem that would justify their congruence would be the corresponding angle postulate, which I'm going to refer to as CAP, the corresponding angle postulate. Okay, so that's the first one. If 2 and 3 are congruent, would 2 and 3 be congruent if these lines are parallel? 2 and 3 are congruent because they are vertical angles, so that would be the vertical angle theorem. All right. 4 and 6. 4 and 6 are supplementary because if 2 parallel lines are cut by transversal, then same side interior angles are congruent. So the same side interior angle theorem. Okay, same side interior angle theorem. 4 and 8. If the lines are parallel, then 4 and 8 are corresponding angles, and they are congruent or equal because of the corresponding angle postulate. All right, keep going. 4 equals 5. Okay, I look at 4 and 5. If the lines are parallel, then 4 and 5 are alternate interior angles, which are congruent if the lines are parallel because of the alternate interior angle theorem. If 2 parallel lines are cut by transversal, then alternate interior angles are congruent. Okay, and last one. Angle 3 is supplementary to angle 5. All right, so I look at 3, I look at 5. Those are same side interior angles. If they are supplementary, then it would be by the same side interior angle theorem. Okay, so we're going to stop there today, and we're going to practice all this tomorrow in class. Hope you have a great night.